So am I live? Okay, hello everyone. I'm Dr. Pankaj Tiwari, instructor for Natural Gas Engineering course. This is 8 weeks, 20-hour lecture course. This is second live session that we are having today. So please feel free to ask any question related to Natural Gas Engineering course. I'll try to answer my best, and you can type in the YouTube chat window, or I think they can come live also and can ask question here. So what I'll do, I'll see the Google Doc file where you might have posted some questions. That is the Google Doc file shared with you from the NPTEL office. And if there are questions, first I'll answer those questions. Second, I'll also take some common question from the portal. That is where you ask the question throughout the course time. And third, I'll take the question when you are posting it either in YouTube chat window or you are asking live. So when I see the Google Doc file, I don't find any question is there. So there is no question. I cannot answer any question there. Second is the question portal or the discussion portal that we got ask the question on the SEM portal. There also I'm not finding any relevant question, technical question related to course. Mostly questions are about sharing the material and other things. So in general, I would like to emphasize we already shared the material with NPTEL office, I think nodal office, IIT Madras. They would be sharing all the material with you in the transcript form, in the video form, or slide form. I don't know. So if you're not able to download or see the content that is required for you or that is allowed for you to receive as a registered participant for this course, please write to NPTEL office. They should be able to rectify the issue. Now, third is our chat window in the YouTube. There also, I'm not seeing any questions so far. So what we will do, we will take a pause of some minutes. I'm still online here. So as and when you come and ping the question, I'll be coming back and answering your questions. So I'm here. You can ask the question in the chat window. As there is no live question so far, as I can see from the YouTube chat window. So what I'm going to do, I'll just quickly summarize the syllabus and wish you good luck for the exam. So in this natural gas engineering course, as you can see in the slide, we designed this course for the 8 weeks. And in first 4 weeks, we discussed briefly about introduction of natural gas. So what natural gas is, what are its application, uses, history, background, lot of the things with respect to production. Before production of natural gas, we discuss about in terms of introduction to natural gas. Followed by in the next week, we reservoir rock underneath the surface. So we also discuss the key properties of the reservoir rock, like porosity, permeability, how to estimate them, and then the other important aspects of the interaction of the gas with the reservoir rock. In week 3, we discussed about establishing the relationship between the flow rate and pressure drawdown when the natural gas is flowing from reservoir towards the production well. That's the condition PWF at the bottom of the valve bore. We also call this as a sand phase. At that condition, we could establish the IPR, followed by the lecture on using the gas well testing methods to characterize the reservoir or to estimate the performance of reservoir, or in other way to establish the IPR equation by the field data. In week 4, we further discuss about from this the gas traveled from reservoir condition to valve bore condition, and then from valve bore it needs to travel to the surface. So from PWF to PHF, we again set up the IPR kind of the equation that's called the valve bore performance relationship. So the relationship between the flow rate and the pressure drawdown that is happening in the valve bore. So this is a vertical pipe. It may be inclined also. So we set up the equation for the inclined pipeline and how to solve that equation. Third one is the choke performance relationship. That is the performance relationship is the relationship between the pressure drawdown and then the flow rate at the surface. That's also called the choke, a device that restricts the flow. So we got the choke performance relationship. And then all these 3 performance relationship actually characterizing the behavior of the gas flowing from reservoir pressure to the surface condition or to the separator. And all these 3 are the relationship between the flow rate and then the pressure energy or the pressure drawdown. These equations can be used to understand the behavior of the gas flow through different sections of the production pipe, reservoir itself, and then the choke. The analysis that's utilize the set of these equations to perform the operation at a particular node that we can choose the bottom condition or the top condition, where the 2 equations will be merging together and the principle of pressure continuity will be applicable. So we can eliminate one of the unknowns. So for example, IPR and WPR, if we are using, the common factor is PWF, that can be eliminated. Similarly, if we are using CPR and then WPR, the common factor is PHF, that can be eliminated by comparing both the equation at a particular node. In the next week 5, we consider the syllabus, that is the natural gas that is getting produced to the surface needs to go through the several field operations. Field operation, why I'm saying, because most of those operations happens at the facility installed at the production site or just nearby the production site. So those facilities installed include the separation. So the natural gas that is getting produced is still having some amount of the oil and water, and some sand particle may also be there. So the natural gas separation 1 and natural gas separation 2 lectures actually include the detail about the separators, principle of separator, design of the separator unit. followed by the dehydration of the natural gas, means removing the water compound from the natural gas, and sweetening of natural gas, means removing the sulfur compound from the natural gas, specifically H2S. And in week 6, we also discuss about the compressor design, because the natural gas need to be transported from surface facilities to the end user. Different size of the compressors are required. So we discuss in detail about the Mollier diagram and other things, how to calculate the compressor duty. The compressor station are required between point A and B to transport the natural gas at a specified pressure and flow rate. In week 7, we discuss about how to measure the natural gas flow rate and then the transportation of natural gas by different means. More detail, we had the pipeline design, where the several combination of series, parallel, and then the complex pipeline system was established mathematically. In week 8, we had a brief discussion about the special issues those appears when we are dealing with the natural gas, either during the production time or during the transportation time. Those we discuss in detail, followed by the unconventional production of the natural gas, like the gas hydrate, shale gas, and other. In the last lecture, I also reviewed the same thing as I'm doing right now. The content of the course was reviewed in lecture number 25. So this is the way the system is classified. Bottom part is IPR, middle part is WPR, and then on the top we are having CPR. Depending on the condition, the performance equation will take different shape. So for example, gas reservoir diluviality, that is the IPR, is written here for the pseudo steady state flow condition, considering the skin effect and non-Darcy coefficient. In Balfour performance, this is for the inclined surface, which is having the theta angle, not the vertical as shown in the picture. And then the relationship was established considering the average value of the compressibility factor Z and then the other properties. In CPR, there could be the sonic flow condition and subsonic flow condition depending on the pressure difference and then the composition of the gas, that is reflected by K value. So the one of the equation for choke flow performance is written here. Second equation is written to calculate the critical pressure ratio. So the concept of critical pressure ratio and based on the classification of the sonic flow condition and subsonic flow conditions are discussed in detail in that lecture. On the processing side, we discussed some of these processes like the separation, dehydration, sweetening means removal of sulfur compound. We did not discuss about separating the fraction of the valuable component from the natural gas before it is sent to the end consumer. Mostly the gas that goes to the end consumer by the name of natural gas, that is the methane gas. So these are the books and the material that has been utilized to design this course and prepare the content. You may consider Goa and Galambor and then this advanced natural gas written at the second point by Michael Economide and others. These two books are very important to do the numerical problems and other things related to this course. So with this, I would like to end my today's discussion, as there is no question in the live session, and this is the second and last live session of this year's MOOCs course on natural gas engineering. So I would like to request you, if you are still having some problem, you can write in the portal. I'll try to answer through the portal also. And good luck for your exam. Thank you. Thank you very much.